How are you, everyone? Today we have a new session of our video series for PLC program tutorial. Today we have a new thing related to the aging, signal aging. So what is a signal aging? For the digital input or digital output, all the time based on the process and the logic, all these inputs are changing status from low to high or from high to low. So sometimes you come to need to recognize the changing from low to high or from high to low logic, and we call this the falling edge, when the input signal or the output signal changing or transits from the logic high logic to low logic. And the other one, which is a rising edge, when it's changing from low level to high level, from 0 to 1, we call it like a rising edge. So imagine in a situation like you filling one tank, and this tank has a level switch, and you want to stop the filling process or running the pump which is used for filling this tank. When the level reaching to a specific value, let's say for example the exactly like 1 meter, so above 100 centimeter it will be stop the tank, and before 100 centimeter it will be start over the pump to continue filling the tank. So this will happen in this situation by recognizing the transition from high to low or from low to high of the level switch itself signal. So here you can see in the this very figure, so this is one input, or you can see the output itself. So if it's changing from high level, which is logic high or 1, to logic 0 or low level, so this is a falling edge. And if it is changing from 0 to high, or from 0 to 1, or from low to high, so this is a rising edge. So how this is symbolized in the our logic programming. So here you can see it's simply for the input to be a contact, simple contact, but I recognize that I am watching the rising edge by both the positive for positive edge or N for negative edge. But when you see here in the actual programming, you will see two tags or two memory variables or two variables of type Boolean. So why we need these two? So I need one in the top. This one holds the previous status, high or low, and the one in the bottom to hold the value of the logic status to be high or low. By comparing the status of the previous and the current, you can see if the rising edge happens or a negative edge happens or nothing happened. In the case of the previous and current has the same logic state and no change in the logic state. Same thing for the output. You use the same coil symbol and both B for positive edge and N for the negative edge. So let's simulate this in our simulator. We open one project and we open the project here. We have made one run, simple run, and this is a contact. You can see the contact, and we put the in. Just you click the contact like this, so you can bring one contact like this, and when you click on this one, you will see the B for positive edge, N for negative edge. So this is very simple. So once you use the B or N, you will have to define two tags, one tag for a previous value and the one tag for the current value, and this is the output. So when the previous value is 0 and the current value is 1, so transition from low to high, So this positive edge will energize the motor, but notice it will energize the motor for only one scan cycle. So after that scan cycle, because if using the push button, so when you press, it will be high, and when you release, it will be low. So now it's like changing from when pressing. If you like when you're pressing, that means you're changing from high to low. So it will be instantly run this motor, but it will stop. It's not continuous. So to recognize this thing, I just make something smart in another run like this, and make this one or we can simply make a contact here. So we can here make another make a latching like this. Okay, and take this one here. Okay, and make stop here like m to 0, and I will do this for stop the motor. So I will cause this one to stop the motor. So once I run the program, oh, I don't have a simulator, so I need to open a simulator first, because now the program gonna ask me what is your controller. But now, as I now have one simulator, so it downloads the program, as you can see, and here we go to run our stuff. So here nothing happened at the beginning. Okay, so what we need to do is like this one to changing from low to high. So once I modify this one to 1, okay, what happened is now, and I put this 0 again. So what happened is it was 0, and the previous was 0, and it's changing to high. Okay, so that one already the motor output is the coil is energized and latched here. Okay, so if I like now press the stop button, it will stop. Okay, and make it again as initial status. So notice it was 0 0, as you can see, and when I changing this one to high, like if I make this one toggle this one, okay, to high, to modify this one is this one modified only based on this one, it's read only. So again, when I modify this one to high, that means I press the push button. Okay, so this is 0 and 1, the transition happened. But once you release your button, so it will be returned back to 0. So it's 0 0, but the latch happened. Okay, showing the position. Let's reset this stop again. Okay, and let's move to the other thing. Like we just stop our simulator and just make this one to be off in edge, and I just open the simulator, update the program, the modified program, run simulator. Now I need to change from high to low. So you can imagine when I make this one, because this is the previous is 0 and the current is 0. So now when I make it on, so you can imagine it was 0 and become 1. That means for positive edge it works, like make the motor energized. But now no, you know why? Because this is a positive edge. But when I release the button, like now the button state, the previous state was 0 and the current state is 1. But now when I make it like 0 again, what happened is it changed from high to low, which is a negative edge. That's why you can see the motor here energized again. Thanks for watching, and I hope to meet you again in something like a new session. and I hope to meet you soon. Thank you very much for watching and see you. Thank you.